Hi, everybody. I hope everybody is doing well. This is our sixth session of Inspiring Future STEM Stars, and I am very excited to introduce you all to our guest speakers for today. First up, we have Dr. Shannon Timmons, an Associate Professor of Chemical Biology and a chair of the Detroit local section of American Chemical Society. How are you today, Dr. Shannon Timmons?
Great. Thank you, Hannah. Thank you for inviting me and welcome everyone. So I'm going to start by telling you a little bit about my STEM journey and how I chose my career and what it's like to be a university professor of chemical biology. So I want to tell you a little bit about me. So where am I from? I am not from the United States. I'm actually from Eastern Canada. So I grew up in a small province on the East Coast called Nova Scotia. It's about 24 hours drive from here. It's a really long way away in a very rural area. It's not even really on the map, but it's somewhere there in a very small community with less than 100 people. And I never in the world would imagine that I would be a university professor in Metro Detroit, but here I am. So I'm going to tell you a little bit about how I got here. So in high school, I really liked all my science subjects, and it was really, really hard to choose what to major in university. I actually started university, my undergraduate degree, at a small school in Nova Scotia called Acadia University in food science and nutrition, because I just had a friend, one of my mom's friends, and she was really, prominent in that area, and she had a really good career, and I thought I really respected that, and so I wanted to follow in her footsteps. But after my first semester of college, I realized I really liked chemistry, and I did really well in freshman chemistry. And my professor approached me and he said, "Why don't you be a chemistry major?" And I said, "Okay." I mean, I was a little nervous because I thought, well, science degrees were hard and I wasn't sure if I was smart enough to be a chemistry major, but it turned out just fine and I did really well. So I majored in chemistry during my undergraduate degree. And I wasn't sure, after my junior year, my third year of college, I got an internship opportunity, which means a job. So I worked for a job in the summertime at a local company that was chemistry related. It was called Biomedica Diagnostics. And because of that job, my boss there actually mentored me and encouraged me to consider going to graduate school because she saw how much I liked doing research and working in the lab. So this is the founder of the company, was Dr. Abby Kiramira, and he actually invented one of the first rapid tests for HIV/AIDS to detect a certain type of virus. So it was a great experience working at that company and getting work experience in kind of the chemistry field. And so I decided after my undergraduate degree, I would pursue more education in chemistry. So I decided to go to graduate school and I applied to a few different schools, and you get to visit them and talk with professors and see if there's a good fit. So I ended up going to another school in Nova Scotia in our biggest city called Halifax, called Dalhousie University. I was actually really interested in medicine at the time, and medical sciences, but I had just earned a degree in chemistry. I knew that being a medical doctor wasn't really the right career path for me because I get really queasy when I get a cut or I see blood or when I see people hurting. It's really tough for me. I faint when I give blood sometimes, and needles are not my favorite thing. And at that time I thought, wow, I don't know if being a medical doctor and working with sick people is really the right path for me. But I was still interested in medicine. And there are lots of ways that you can major in different degree programs and have an effect on medicine without being actually a medical doctor. That's only one path. So then I learned that with my chemistry degree, I could focus on a specific type of chemistry that related to medicine, helping to make new medicines for people, called medicinal chemistry. So there's a whole area of chemistry that focuses on making new treatments, making new drugs to help people get better. So that was the focus of my PhD. So we actually made new molecules and then tested them to see if they would treat people who got bacterial infections or cancer. So after spending my whole life in Nova Scotia, all through my university career, I decided I would do an internship. It's very common after you go to graduate school, a postdoctoral fellowship. So it's like an internship for people who have just earned their graduate degree. And this is when I moved to the United States. So I moved to Wisconsin because there was a very good drug discovery group working there that I really admired. And I had done research on them and looked into their lab, and that's really where I wanted to go and learn more things. So I moved to Wisconsin and I did a postdoctoral fellowship there. And so I did more research in a drug discovery lab and learned some new skills and techniques. So after Madison, my husband also earned a PhD in physics at the same time as me. So then we had two of us who were looking for jobs in science, and it ended up that he actually got a job at GM here in Metro Detroit in material science. He worked on lithium-ion batteries to make electric cars and like hybrid vehicles. So at the time, he had met some people at GM, and through networking, I ended up meeting who became my new boss at Lawrence Tech. And at Lawrence Tech, through networking, I realized that they had an open position for a professor. And so I applied for that one job, and I came and interviewed, and I got the job. So I think talking to people, and networking is really important, like you're doing here today. Meeting lots of people and talking to people who are working in areas that you might be interested in can really help you, advance in your career goals and allow you to explore your interests. So at Lawrence Tech, I'm a professor in our campus, beautiful campus in Southfield, and I teach two areas of chemistry that are both related to chemical biology. One is organic chemistry, the study of compounds containing carbon, and the other is biochemistry. So that's what chemical biology is, a lot of different facets. And I'm really in primarily like the drug discovery arena at Lawrence Tech. So I have undergraduate students who work in my lab. They can start as early as your freshman year. You should start to try to think about getting involved. We even sometimes have high school students who come to do research with us. And we run a lot of summer camps. I run a molecules and medicine summer camps for anyone entering like 9th through 12th grade. So, you can get involved when you're in high school, volunteer, come to a summer camp and kind of explore what kind of skills and techniques, what the field might sort of be like. So you have an idea of maybe what you might want to major in college. Although you can always switch like me, because I started in food science, I ended up in chemistry, and that's okay. In your first year or your first 2 years, you take a lot of similar courses, whether you major in any science, you take a lot of similar, so you can always, get there, and it's okay to switch, it happens. But yeah, you want to explore different fields as quickly as you can to sort of get an idea of what might be a good fit for you. So one project we work on, this is my research lab at Lawrence Tech, kind of a panoramic photo. So we have lots of what we call chemical fume hoods. Those are like shown here. Those keep us safe. So those are where we use all the dangerous chemicals, and we always use like safety glasses and gloves and all kinds of things, and extra ventilation to make sure you're not exposed to anything dangerous. And we have lab benches and desks, and my students, they work in the lab. And what we do, we take a molecule that already exists. In this case, I'm showing salicylic acid on the screen. That's actually a medicine that is used in acne medications. I don't know if any of you have ever used like a face wash. If you ever use a face wash, if you're a tween or a teenager, you may use face wash. You could check the label and it might have salicylic acid in it. So it's really interesting. Salicylic acid is actually found naturally in willow bark. So I actually work on natural products chemistry. These are chemical compounds produced by living organisms. And a lot of the drugs we use actually are derived in part from nature. So salicylic acid, you can grind up willow bark and actually extract it. And it's used in acne medication. But it's not good to ingest because it is a pain relieving drug, but it's hard in your stomach. So it'll give you a stomach ache that sometimes can be worse than the pain that you might want to cure. So it wasn't, originally they tested this drug for analgesic, which just is a fancy word for pain relieving drugs, but they found that it wasn't that effective because it caused stomach pain. So what we did was we made aspirin. You know, many years ago, 1899, aspirin was first approved for use. It's a very old drug. So if we change the structure a little bit and we add some atoms to it, it becomes aspirin and becomes safe and effective to use. What we're doing is we're trying to change the aspirin scaffold even more and add more atoms and then test what happens when you do that. So R here is what we call a variable unit. So that can be anything. It can be 10 carbons, it could be 5 carbons, it could be all kinds of different arrangements of atoms. So that's just the part of the molecule that we change. And then we actually test the molecules to see what they do, their medicinal properties. And I'm particularly interested in antibacterial agents. That's just a fancy word for antibiotics, because it's really important that we continue to discover new ones. And anti-cancer agents as well. Some aspirin analogs have been used to treat non-small cell lung cancer. So there's some interesting uses. So we change the structure a little bit and then see what it does in my lab. That's our main focus. And we actually do this in our courses. So we have a big program called Course-Based Research Experiences at Lawrence Tech. We have a grant, and so we bring research into the classroom. So I have students who are sophomores in their second year of college, and instead of doing old experiments that we know will work, they work on these research projects instead to learn the skills and tools that they'll need to succeed after their degree. So it's a really exciting place to teach and a lot of fun. So my favorite things about being a professor, it's probably doing research is one of my very favorite things, and actually having students in the lab with me who I get to teach and mentor, and then helping them reach their career goals. I just had a student email me, he got into dentistry school today. It's really exciting to be able to help students reach their goals and, realize and reflect on what career might be best for them. So that's really one of my favorite things. And I bring research into my teaching. So it's really exciting opportunity for the students, and it's so much fun for me. So my last slide is just some advice before I'm happy to answer any questions that you might have. I see a lot of comments in the chat, so I will get to those for sure. So advice, Hannah asked me to think about some advice I might give students who are interested in STEM careers. So some advice I came up with was first to volunteer early, sort of try to get involved in STEM initiatives so you can kind of explore your passions as early as possible. The more experience you get, kind of the more focused you'll be, when you decide to go to college, you'll have a better idea of what area of STEM you might like to focus on. So you could go, it's not volunteering, you could register for summer camp, or you could be a summer camp counselor, science summer camp counselor, for example. If you wanted to kind of try out how that felt, you can volunteer with different nonprofit organizations like the Michigan Science Center, has programs and volunteer opportunities, for example, that you could participate in. In high school, you could potentially even volunteer in a research lab if you want, in the summer or after schools. There are certain opportunities there. The American Chemical Society has a program for high school students called Project Seed, and that allows students to get in research labs and do some work and earn scholarships and things. So there are programs out there. You just have to be looking for them and connect with your teachers and guidance counselors, reach out to university professors if you're interested, and eventually, and explore your STEM hobbies. So see what you enjoy doing. So you can join clubs, like at your school, they might have clubs related to STEM, or like robotics or science. You might participate in Science Olympiad. I know that's like a high school program, you know, that is possible. Or Chemistry Olympiad is a high school program for students interested in chemistry. The Detroit local section always sponsors our local Metro Detroit Chemistry Olympiad. There are science fair opportunities, the big Metro Detroit Science Fair. So just getting involved and experimenting and seeing what's out there and networking with different people is a good way to get started. And I guess math is important. I just need to say this, it's fundamental and foundational to all science degree programs that you're going to be pursuing. So even if you don't want to do math every day, my area of chemistry is honestly not very math intensive. I'll be honest, mine is probably the least math intensive, the closest to biology. But to earn a chemistry degree, you do need to take lots of calculus, you know, and math, because it is foundational subject. It's important for some sciences in everyday life. My husband still does math as part of his job. So it's really important to get a strong foundation in math. Will give you a lot of choices. It's not like you have to do math for your career, but if you can do math, you know, and you work hard and you can persevere through your math courses and do well, you'll have so many opportunities to choose from so many different fields, you know, because it's probably the number one area where college students kind of struggle in STEM degrees. So that would be my advice. Work hard in math, try to explore different subjects. Yeah. So thank you so much for listening. I hope you've all enjoyed the presentation. I'm just going to look at some questions now. Is that okay, Hannah? Or would you like to go through the questions and sort of ask?
Of course. So does anybody have any questions for Dr. Shannon Timmons? Please feel free to unmute yourself or use the raise your hand feature on Zoom. So I'm not sure if anybody has questions just yet, but I do have one actually. So what has been your favorite part about working in the lab and being a professor?
I think it's seeing students make breakthroughs in the research lab and make new discoveries. I mean, that never gets old. We just, you know, found a way last week, a new way to purify compounds and make them in much higher yield than anyone had ever done before. It's just the excitement of discovery just never gets old. And now I'm working on a journal article right now. So we publish our work. So it's really exciting for students and to see students and for me to be able to publish the work we do in the lab. That goes in a journal article and then everyone around the world can see it. It's indexed in databases internationally, and to go to conferences as well and see people present and disseminate their work is really exciting. So just making discoveries and seeing students, you know, be able to be published authors and helping them succeed in their careers is really the best part of my job.
That's fantastic. Would you mind walking us through a brief kind of, I don't know, skeleton of what your day is generally like at work?
Oh, that's a great question. So I'm at a small school. Lawrence Tech is like Acadia University where I went. So I love it because it's about, you know, we probably have about 2,500 undergraduate students. So I know every one of my students by name. So no one's a number. So I love getting to know them. So, you know, my day, typically I would teach 3 different classes per semester. And in university, classes meet for 3 hours per week in general. So this fall semester, I'm teaching 2 laboratory classes. Laboratory classes are always 3 hours long. So we meet once a week for 3 hours. And then my lecture classes, I'm teaching Organic Chemistry 1, that's 2 75-minute classes. So I usually teach about 3 to 4 days a week. I'll have 1 class. So it really is different every day, but I go in, you know, and I'll teach my class, might have a class most days, you know, for at least an hour and a half to 3 hours. I'll meet with students after class, make sure they answer all their questions. Then I'll go to the research lab. So I schedule times with students when I'm not in class to work in the research lab and move those projects forward. I work on writing projects. I serve on a lot of committees. I'm the director of the honors program right now at Lawrence Tech. So I do some committee work and administrative work as well. So it's really a good mix of things. And I love it because no day is boring and no day is the same, I guess. And I also take time to grade assignments and prepare for class as well. So I do all of those things every day. It just kind of varies how much time I spend depending on my class at that particular day.
That's really cool. Thank you for sharing. Does anybody else have a question for Dr. Shannon Timmons? I don't see any in the chat.
Okay, great.
Thank you so much for coming out here and inspiring all of these wonderful young participants.
Well, thank you for having me. And, you know, Hannah has my email address. If anyone has any questions or wants to come visit my lab sometime, you know, we could set up a tour.
Okay, that'd be fantastic. Thank you.
Thanks, everyone.
Have a great day.
You too.
Okay, so it's time for our next guest speaker, Ms. Rebecca Snyder. Would you like to share your screen? Thank you for coming.
Yes, let me start here. Oops. Okay.
Rebecca Snyder is an advanced placement chemistry and high school chemistry teacher. So.
Yes, okay. Okay, can you guys all see my screen okay?
Yes, we can. Thank you.
All right. Well, welcome everybody. I'm excited to talk with you today. And yep, as Hannah said, I am a chemistry and AP chemistry teacher, but I've taught a lot of different things. And you may say, oh, you're a teacher. I know what you do every day because I get to see you every day. You might be surprised on the things that I have to know that, well, what teachers have to know. Teaching is a very interesting job. And a lot of times we forget that since we were in a classroom doesn't necessarily mean that we know what teachers do. It's especially nowadays. I understand, as you guys do, my school just announced that we're going 100% virtual. Many of you guys are probably too, and it's scary, it's different, and it's new. So we're all kind of in that one together. Anyway, so what is my job? Well, as you know, I'm a teacher. And like I said, you kind of know a lot about what I do. I teach kids, but there's a lot more to it than just that. So I've been a high school teacher for 20 years, actually. This is my 20th year. I can't believe it's been that long. And I've taught all these different subjects: chemistry, AP chemistry, earth science, environmental science, physical science, a lot of different subjects throughout my career. My favorite is chemistry and AP chemistry, though. That's what I really like to do. That's a picture of my AP chemistry class. Every year we do a mole week, which mole is a number in chemistry. And it's gotten so big in my school that now it's a theme. Every year has a theme. This year's theme, or well, in this particular picture, was Incredimoles. So we've had many others. I can see Anna's like, yeah, okay. She understands all of this. And this is type of the stuff that you'll look forward to in high school one day too. So one of the things my AP chemistry students have done now for a few years is we actually travel to our local elementary school that's just down the road, and we actually do presentations, chemistry demos, and last time we actually did hands-on activities for the elementary school students to do. So you guys would have been part of that presentation that we did, and it is a lot of fun. I picked this picture because they're actually doing an experiment with dry ice, which is what you're doing today, if I'm right, yes?
Demos, yeah.
Yes, okay. So now, actually, Dr. Timmons talked about Science Olympiad, which is something I was going to talk about too. I am also our Science Olympiad coach, and this is one of my Science Olympiad teams. If you like science, you would love Science Olympiad. It's a competition-based thing. Some schools have a team, some schools don't, but all schools could have a team. So you may want to talk to a favorite teacher. Sometimes parents will coach. Sorry, parents who are out there, if I put you into something. So anyways, it is so much fun. It is a lot of work, but that day of the competition is great. And you can see you win medals and that sort of thing. This is actually, my daughter's in the middle, and this is their elementary school Science Olympiad. So Science Olympiad is for all ages, and it's just a blast. As Dr. Timmons also talked about, there's things like robotics that you might be interested in. I actually coached a robotics team once. There's ones that are really competitive called FIRST robotics. So if you're interested in any of that, there's these things out there, and it is for your age group as well. They are there. So something to look into, something to ask. I also have run a science club before in my school. So just a way to just do fun activities in the school, just to do more science than what you actually get in a classroom. So, okay, so how do you become a secondary teacher, if that's something you ever want to do, okay? So first of all, what's interesting is secondary teachers actually have degrees in their subject. I have a degree in chemistry, not in education. Elementary teachers have degrees in elementary or in actual education, but secondary teachers don't. So I have the same undergraduate degree, I believe, as Dr. Shannon does. So it's the same sort of thing. So I know a lot of chemistry. Now, secondary teachers also have to have what's called a minor in a subject that they teach. My minor is in earth science. So that's why I can teach, that's why I've taught all these different types of courses, earth science and environmental science, because I have degrees in both of those things, okay? And actually my chemistry background made my earth science understanding so much stronger, because I could actually look at the chem and put it together with the concepts that I was looking at in earth science. So I went to Michigan State University, go State, have to throw that out there. And the reason I chose Michigan State is simply because I knew I wanted to be a teacher, and Michigan State has one of the best teaching programs in the country. So that's my reason for choosing that, if you wonder, okay? Now, as a side note, I also have another thing called an educational specialist degree, which is something that outside of the world of education, not many people know what it is, but it's kind of in between a master's degree and a PhD. I'm like a few credits short of a PhD type thing, but it's specifically in education, where I specialized in writing science curriculum. So I've actually wrote a couple things that your teachers could use in the classroom to teach you, okay? Okay, so now here's the interesting stuff, I guess. So why did I choose teaching and chemistry? So I knew I wanted to be a teacher ever since middle school. It was just one of those things that hit me, and I just, that's always what I wanted to be. I don't know why, it just is. A lot of teachers will tell you it's a calling or something, okay? But that's what it was. Now the thing was, I also knew I loved science. So I knew I was going to be a science teacher, but I did not know what I was going to teach, because this is the best part. I absolutely hated chemistry in high school. I hated every second of it. I vowed never to take it again in my entire life. And then when I went to college, they told me my first couple of days when I was signing up for classes, they said, guess what? You're not going to take chemistry right away, or you're not going to take biology right away, because I started as a biology major. They said, you need to actually take chemistry first. And I was like, oh, like, you know, that deer in headlights look, like, oh my God, like I thought it was, I didn't know, like bad things. But it turned out I went to my first chemistry class in college. I loved it. Started talking with the professor, loved it, loved it, loved it. And that's when it hit me. Why did I hate chemistry so much? Okay, there's got to be a better way. And I me to go out and show kids how amazing chemistry is. And that's basically how my career got to where it is. So a lot of teachers will tell you, oh, there's a teacher that inspired you. Well, I guess I have a teacher that inspired me too, not exactly positively, but I thought there's gotta be a better way to teach chemistry to show what a really cool science it is. And I think I've done that. Kids love my class, kids love coming to my class. I've increased the amount of kids that take chemistry every year by 60%. It has been wonderful. So it's amazing what you end up. You never know where you're going to end up, ever. And Dr. Timmons had a very similar story. So now, what I thought I'd do is show you how my STEM knowledge is really put forth in my job, okay? I mean, obviously I teach chemistry to students, that's obvious, right? But what's not obvious is all the background thinking that sometimes I have to do. So I have two very interesting stories for you. So my first story is about Kenny. Kenny is interesting. So Kenny is a student I had in chemistry, and when you go into chemistry, your first chemistry class, what kids always say to me is, I want to blow something up. I mean, that's why you take chemistry, is to blow something up, right? Okay. So some of you might think that too, like, oh, she can blow something up? No, I'm not, sorry. But a lot of people think you mix two things together and it might blow up. Well, spoiler alert, there's not really a whole lot in chemistry that actually would do that, but everyone thinks there is. Kenny thought, I'm gonna find that thing that you can mix together to blow up. Okay, fine. Well, I had a lab out for some other classes, and Kenny said, I want to mix these things together. And I'm like, all right, Kenny's got to get this out of his system. I'm going to let him mix stuff. So first, Kenny said he found some salt, some NaCl. Okay, fine. And he put it in some water. And so you get that. Okay, fine. Yep. Then Kenny says, can I throw this in there? Sodium sulfate. Sure, Kenny. Go ahead. Throw it in there. Let's see what happens. Yeah, nothing. It stayed that way. Right. So then Kenny says, hey, there's this little dropper bottle and it has this which is pronounced phenolphthalein in it. Sure, Kenny, go ahead, squirt some in. Let's see what it does. At this point, Kenny is really angry at me. Kenny's like, come on, you tricked me. Nothing so far. Fine. So then Kenny is getting mad. And so he says, he grabs some window cleaner that I have out to clean the lab. And he goes, I'm going to spray some window cleaner in there. Fine, Kenny, if you have to, go for it. Whoa, pink. Now Kenny was interested. He's like, whoa, got pink? That's crazy. What Kenny didn't know is that in window cleaner is something called a base. And that phenol blah, 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 the phenolphthalein stuff tells me there's a base by turning pink. So then Kenny says, I got some bleach. And I go, whoa, stop, Kenny. Whoa. At that point, I had to stop Kenny. Now, Kenny thought he's getting away with everything because he's just tossing stuff in, and I'm like, sure, go for it, Kenny. Sure, go for it, Kenny. Now, after a while, my students learn that if I'm like, whoa, stop, then actually then they found something interesting. So in window cleaner, the thing that made it turn pink is called ammonia. And a good thing to always remember is that bleach and ammonia make a really deadly gas. So if you're ever cleaning, this is one of those things that everybody should always know. If you're ever cleaning anything, never put bleach and ammonia together. Never spray window cleaner and bleach. You get really bad results. And people, there was just a story a couple days ago about a person at a Buffalo Wild Wings that almost died because of that. So yeah. So this is what I do in a day. This was not part of a lesson. This was not something I was teaching, but it also got Kenny to start thinking about science. And it also, I had to follow every step along the way of what Kenny was doing. And I had to know what was going to happen with each progressive step that he did. And actually, I shortened this story. I would say he actually probably mixed closer to 10 things together. But there it is. Now, my next story, the hood fire. Now, as a chemistry teacher, I have to admit, I've had a few fires, just a few. There's some garbage cans that Actually, the joke is that I usually have to have a new garbage pan every year. It's not that bad, I don't think, but whatever. So the hood fire. Okay, now, Dr. Timmons also pointed out to you guys the hoods in her laboratory. This is a hood, okay? And you put things in there and then you switch it on and then it like sucks out bad fumes so you don't have to breathe them in. Well, it also does things like it can protect fires and things, okay? So I had a student who was doing an independent study with me. Now, an independent study class is something you may think about in the future. It's for students who basically have no other class to take because they've taken so many. And he was actually doing a chemistry project on his own. And he was doing what's called a distillation. And he was doing something where, see how there's like a beaker of water in here? That water heats up and then heats up the stuff that's inside this funny looking round flask. Well, the water heating up would not have been hot enough for what he was doing. So he decided he's going to heat it up using oil. Well, he says, I'm gonna leave this here and let it heat up. You need to watch it. Well, I'm a teacher. I have a million things going on. So I can't really watch his experiment. Well, we decided let's throw it in the hood too, just in case. Well, it was a good thing we did the just in case, because what happened was this oil that was in here got so hot that it heated up to what's called the flash point. So the flash point is the temperature at which something spontaneously combusts. In other words, you don't need to put a match to it. It's so hot that it just goes on fire. Right. So all of a sudden, there are flames coming out of this part of my student's experiment in this hood. And luckily, it's all contained in the hood. And so, okay, so here I am, I'm looking at this fire and I'm thinking, well, what could I do about this fire? So here we are. I knew it was a grease fire because it was oil. Okay, so the first thing you do when you have a fire, you think, I'm gonna put it out with water, right? Water, that's what people do. No, it's a grease fire. Grease fires actually get worse with water. Certain types of fires, whatever you're burning, you have to know what's going on. That type of thing would have been worse with water. So I couldn't do that. So I quickly did bring our fire extinguisher because in my lab, there's a fire extinguisher because these things happen. So fine, there's a fire extinguisher. I brought that over and I thought, okay, if I need to, I'm gonna use the fire extinguisher. But here's the problem with the fire extinguisher. It's not one of those cool carbon dioxide ones like their dry ice that you're gonna look at later, where you see people like, you know, spinning on chairs and stuff on YouTube. If you haven't seen that, don't look for it. And so, but anyways, this is a dry chemical one. This one is really bad for you to breathe in. If I used it in my classroom, we'd have to evacuate the classroom. We'd have to get somebody else to clean it up and all of that, which probably is better than burning the school down, but still, okay, not the best choice. So I thought, okay, fire extinguisher, not the best answer, but I'm gonna keep it near me just in case. So actually what I did was absolutely nothing. I did nothing. And you might think, okay. All I did was I sat there and I watched it because I knew that this fire was contained to this one beaker. It had oil in it. I knew that eventually its fuel source was going to run out. And sure enough, in about 2 to 3 minutes, the whole fire went out. This whole entire thinking process and the whole entire thing happened within a matter of minutes. But I'm the one who had to sit there and make all these quick decisions to decide, how do I deal with this? And it's my STEM knowledge that actually brings all of that out, not the teaching knowledge. I think the best part was when I explained this to my principal and I started with, well, I had another fire. Sadly, I had to start with another fire in my classroom. And he says, okay. And I go, yeah, and when you probably see it on the internet because a bunch of kids were filming it with their cameras and phones. He's like, okay. And I go, and when you look at it, it's gonna look like I'm not doing anything about it. And he's like, oh, okay. And I said, but let me explain why. He was like, all right, yeah, I guess you made the right decision. So really, I have to use my chemistry STEM knowledge a lot in my classroom. And that's only 2 examples. There has been many others. Anyways, I didn't want to spend a lot of time, but if I wanted to give you a couple questions or a couple things, tell you a little bit about how to become a teacher and show you that there's a lot that goes on in the mind of a teacher, especially once you get into the harder sciences. AP chemistry, if you're not familiar with AP, by the way, AP stands for Advanced Placement. That class is actually a college level chemistry course, and my students actually can earn college credit for it when they are done. So I have a lot of knowledge, a lot of STEM knowledge that I use on a daily basis. So do you have any questions or anything?
What would you recommend for, I guess, people, I don't know if this is a good question, for people interested in AP Chem or like teaching a science class? I don't know.
To be a teacher, or if they wanted to take it as a student?
Both?
Okay. Well, as a student, to do AP or advanced placement classes, and there are many, 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 not just in science, but in all the subjects, you want to have good grades. You have to be able to think. You have to be able to be stressed, I guess is a good word for it too. I mean, they are college level courses while you're in high school. And so it's, I like to say for my kids, I go, AP Chem's not for the weak. So it's not, but I think it's the most rewarding experience ever. Some of my students don't get the college credit. I'll admit it. However, when they go to college, their chemistry classes in college are easy. And they all tell me, super simple. I breezed right through college chemistry, which is something not many people can usually say. So if you want to be a teacher, usually teachers don't start with teaching AP courses. Usually you start with teaching physical science and then kind of as time goes on, but not always anymore. I've met first and second year teachers that were doing AP. So really, teaching is its own thing. If you like science, good, but you have to be able to want to share all that knowledge, and you have to be patient, you have to be willing to listen. I mean, really, the things you see in your classroom every day is what I have to deal with as well.
Does anybody have a question that they'd like to ask Rebecca?
No.
No.
Okay, thank you so much for coming. It was really inspiring to hear your STEM story, and I appreciate you taking the time.
Excellent. Well, I'm glad I could be here, and I hope you guys end up doing whatever it is that you want to do in life one day. Don't quit, don't stop. Like me, I hated chemistry, and I ended up being a chemistry teacher. So you never, ever know where you're going to end up. Just keep an open mind.
Thank you.
Yep. Bye.
Bye.
Bye. Mai, can you go tell mommy the cloud starting? The cloud thing starting? What are you doing? Mai, now.
Okay, so I'm going to start sharing my screen and we'll begin the experiment section. So our first experiment is the cloud in a jar. Oh, 1 second, just got technical difficulties. Okay, so lab safety. In this experiment, it can be kind of dangerous if you don't handle your materials properly. So you're going to want to make sure that you're wearing your safety goggles, and remember that hot glass looks the same as cold glass, so be very careful and don't touch it with your bare hands. Use a pot holder or an oven mitt, and don't handle the hot glass or water with your bare hands. Make sure that you're tying back any loose hair and you're not wearing anything that can drape in front of you. And have adult supervision for this experiment, because you should let them handle the hot water and glass because nobody needs to get hurt. Okay, so for the experiment, your supplies that you are going to need are a glass mason jar with a lid, 1 cup of hot boiling water. So for this part, make sure that you have an adult, parent, or guardian, older sister, older brother, deal with the water because nobody needs to get burned. Food coloring, it makes it easier to see the cloud in the jar, and aerosol hairspray or another aerosol product, but I recommend aerosol hairspray because I know that works. Ice cubes, you're going to need about 4, and they're gonna sit on top of the jar, and oven mitts or pot holder to handle the hot water. So I'm gonna go through the written instructions, and as always, I have a little instructional video where I kind of go through all the steps for you guys. So our directions. We are going to put 1 to 2 drops of food coloring into our water. Then we're going to put a cup of hot, then never put boil the water. Okay, you are going to heat up your water to the point where it's almost boiling or just boiling, because you don't want to be super crazy hot. And then once it's boiling, you're going to pour a cup of it into the glass jar. You're going to quickly spray a bunch of hairspray into the jar and quickly put the lid on the jar. At that point, you're going to put 4 ice cubes on the lid, and you're going to see something similar to a cloud form in the jar. And when you open it, it'll kind of move out, and it's really cool. So I'll start the video. Let me know if you hear it, if you can hear it, because I'm not sure if I ended up sharing my computer audio. So what you're going to need is hot boiling water, which I have heating up right now on my camp stove, a glass mason jar, and a lid for your mason jar, food coloring, aerosol hairspray, and ice cubes. So you're also going to want adult supervision, because this can be dangerous since we're using a heat source and hot water. Also remember that hot glass is the same as cold glass, so be careful when dealing with your jar. Make sure you try not to touch it with your bare hands, and also keep your hair tied back. So I'm going to check on my water, and it is definitely boiling. So I'm going to turn that off, and I'm going to very carefully pour it into this glass. I have already dyed it blue. Now I'm going to spray a bunch of hairspray in and quickly seal the jar. So we should be able to start seeing a cloud form after I put about 3 to 4 ice cubes on the surface. You can't really see it too well in the video because I was filming outside of poor lighting, but it should be like white, almost steam, but it kind of looks like a cloud in the right lighting. So you can kind of see it. I'm on the best lighting right now. And you can kind of see the clouds starting. So right now, yeah, you can. Now I'm going to open the jar, and we're going to be able to see the cloud move out. Okay. Hope you enjoy. So hopefully that worked for everybody who tried it. Does anybody want to share their observations?
Yes, my observation was when the hot water was pouring in, and when we put the ice at the top, the clouds started moving up and evaporating.
Oh, cool. Would anybody else like to share? I'm gonna check the chat because somebody wrote something. Okay. So our next part is, why does this happen? So we're almost kind of simulating the water cycle in a way. So the warm water molecules, they're vaporizing into a gas state, and they're gonna rise to the top of the jar. And since the ice cubes are on top, the water molecules are going to cool down, and they are going to condense onto the super small hairspray particles. And this forms a cloud in the jar. So that's kind of what we're seeing. So that's just research sources. So our next experiment, well, not experiment, our next project is, oh, somebody said that they opened theirs and smoke came out of it. Yeah, that's pretty much what happened. Thank you for sharing. So we are going to make a paper circuit bookmark. So I have a couple of examples, and I'm gonna make one with you guys. So what you're gonna need is a CR2023 battery. I think it's lithium. It should look kind of like this. If you received a STEM kit, this is just the ones that I put in there. And then you're going to need conductive copper tape, which looks like this. LED lights. This is a really huge package, but they look like this. And a paper clip, which should help keep it, it'll close the circuit once we get to that point. And scissors if you need them, and glue sticks. And if you want to decorate your bookmark with markers or stickers, you are more than welcome to do that. And if you don't have the materials at this point, don't worry, this will be on YouTube for later viewing if you want to complete it at a later time. So just to give you an idea of what we're gonna make, so they kind of look like this and they light up. And then there's like two ways that you can make them. You can have a foldy one that's like this when it's open, and when you close it, it lights up. But my battery's almost dead. And then you can also make it kind of like this, where you just fold the bottom over. And I've used this a lot, so the light isn't super bright, but wait, there he goes. Yeah. So a little about circuits. There you have your battery as your power source, and the LED has two ends. The longer one is the anode, which is positive, and the shorter one is the cathode, which is negative. And those are just some examples of different types of circuits. So you have two options really, or you can design it however you wish. This is kind of an open one where you're going to have just two lines of conductive copper tape and the battery and the LED. So, or you can do it this way, which is open and close. You fold it and it kind of conceals the circuit. I'm going to show you the open way because I think it's kind of easier. So you're going to take your paper and you're going to cut out a rectangle or whatever shape you like. Kind of look like, it should kind of look like this, but however you do it is perfectly fine. And you are going to kind of fold it over to create a little flap. I'm doing this quickly so it's not perfect. So it should kind of look like this. We're going to get two strips of copper tape. And we are going to put them onto the bookmark, and I'll kind of like that, how it's seen on these slides. can't get the backing off. Okay, so once you put the copper tape on, you want two parallel lines. So mine's kind of like this, not finished yet. So kind of like this. And this next part is kind of important. You're going to take your LED. Well, I have to open my battery. Okay. So you have your battery and you are going to take your LED and kind of fit it to it and see if it lights up. And if it doesn't, that means it's the wrong way. So the longer end should be touching the positive end, and the shorter end should be touching the negative end, and that will complete the circuit to make it light up. So you're gonna take the LED, you're gonna slide it underneath the copper tape so that both sides are touching copper tape. So it's kind of like this. Or you can use tape just to tape them on top. I didn't want to use tape, so I just kind of shoved it underneath. Okay, so you're going to align the battery so that the positive end is touching the side where the LED, the positive lead is. And when you fold it over, it should light up like this. So that means that you have it on the correct side. So once you know the correct side to glue the LED to, sorry, the battery, my bad. You're going to glue the battery so it's on the correct side, and then fold over the paper, and it should light up when you complete the circuit by folding it over so that the other side of the copper tape touches the battery, like that. I'm sorry if that was confusing in any way. If you have any questions, feel free to ask me and I can try to explain it better. Did it work for anybody who tried it? Okay, Becky's iPad, it didn't work for you. Okay. It might be because your battery is facing the wrong way. So try flipping your battery so that the positive and negative sides are reversed. And that might fix it. Hopefully that helps. Was anyone able to get it to work?
It worked for us. It worked for us.
That's awesome.
How about this?
If you have multiple LEDs, you could also experiment with seeing if you can get more than one to light up at once. I don't know. I've never tried it. I'm gonna see if it works. I can see a couple people's working. That's great. If you have a question, feel free to ask. When everybody's ready, I can move on to the next slides. Or I think the next ones are the dry ice demos, so I can play the videos while everybody else is working. Okay, so dry ice demos. So what is dry ice? Dry ice is frozen or solid carbon dioxide, so CO2. Dry ice it sublimates and changes phases from a solid to a gas. It doesn't become a liquid in between. So dry ice is extremely cold. I cannot stress that enough. It is negative 109.3 degrees Fahrenheit or negative 78.5 degrees Celsius. That means it has to be handled with extreme caution. So you have to wear really thick insulated gloves and safety goggles because you do not want to touch it with your bare hands. And it needs to be handled in a well-ventilated area because the carbon dioxide can displace the oxygen, making it very difficult to breathe. So that's why I did it outside. So fun with dry ice. I have to let you all know that these demos are for educational and entertainment purposes only. So please do not try them at home as they can be dangerous because you just shouldn't do them. I don't know. Unless you have parent supervision and proper equipment because nobody needs to get hurt. So demonstrations. I'm going to be making fog with dry ice and water, screaming dry ice by holding dry ice with warm tongs. And it screams because there's the creation of gas from the phase change and as well as a change in pressure. Dry ice bubbles with soap, a crystal ball, putting out a match, and carbonating a beverage. So first up, we have our screaming dry ice. I shortened the videos for this session, but you can watch the full ones on YouTube. Hope you enjoy. You can also make dry ice fog by taking dry ice and putting it in a glass bowl with water, because the water is a lot warmer than the dry ice. It sublimates at a much quicker rate, and that's why you can see the fog. Hi everybody, so in this video I'm going to show you dry ice sublimating from a solid to a gas. So I have a glass bowl, and I'm going to pour some water in it. And then I'm going to use my tongs and grab some pieces of dry ice to put in the liquid. So if you've ever been to like a Halloween party or something, you might have seen something like this, like a smoke machine. So what's happening is the dry ice is becoming a gas, and that's what you see coming off the surface. See if we can put some more in. Cool, right? Okay. So you can also make like bubbly foam with the dry ice using a water and lots of dish soap. Hi everybody, so in this video I'm going to be showing you dry ice with lots of bubbles. So what I have is a full glass, I think it's a vase, and I'm going to be pouring some water in it. That should definitely, possibly change. Okay. So now I have my dish soap, and I'm going to put a large squirt of it in there. Yeah, okay. So now for the fun part. I'm going to be putting in dry ice, which is going to sublimate to a gas, creating bubbles. So it's going to turn into this really cool foam that we can touch and squeeze. Okay, so I'm going to put some big chunks of dry ice. So you can even touch it. It turns into gas. It's really cool. So you can also make a crystal ball by putting dry ice and water, taking a piece of fabric that has been soaking in water mixed with dish soap, and running it across the surface of the dish. Hi, so in this video we're going to be making a crystal ball with dry ice and soapy water. So I'm going to pour in some water. And I'm going to take a chunk of dry ice. And I'm going to put it in the water. And what I have here is a cloth that has been sitting in soapy water. I'm going to lay it across the surface. So I get it nice and flat. and run it across. I popped it. So basically it becomes like this really cool large bubble just full of the carbon dioxide vapor, and when it pops all of that gas dissipates and release the gas. And you can also use the carbon dioxide gas from the dry ice to extinguish a match or a candle, because when things burn, they need oxygen. There's a saying that my chemistry teacher taught us, reacting O with CHO or CHO always produces CO and HO, carbon dioxide and water. And you need oxygen to make things burn. And the carbon dioxide is more dense than the oxygen gas that the flame needs. And essentially it displaces or kind of gets rid of all the oxygen, like where the flame can't reach it. So essentially it puts out the candle. So it's actually a really cool demonstration. So in this video, we are going to be showing how you can extinguish a candle using the carbon dioxide produced from the sublimating dye ice. So I'm going to pour some water. I accidentally got dry ice in here, so it's kind of foggy. So, actually that's too much. So I'm going to be putting some dry ice into the water. So we can get a bunch of gas created. Well, not created, the phase change it. So then I am going to light a candle. Don't try this at home. It's very cold. You don't want to burn yourself. Okay. So I have my match, my candle lit, and what we see here is carbon dioxide gas. I'm going to pour it onto the candle, being careful not to let the water go onto it, and it should put out the flame. So this happened because the carbon dioxide is more dense than the oxygen, and the candle needs oxygen because the combustion reaction, it needs oxygen to burn. So since the carbon dioxide is heavier, so it like displaces the oxygen, the candle can't burn, so it goes out. Hope you enjoy. Kayla, you raised your hand. Did you have a question? So you can also pop or soda, depending on where you live, it's called different. It's bubbly because of the carbonation, and you can actually make just a normal drink like Kool-Aid, which you'll see in this video, become carbonated and fizzy using dry ice. So in this video, I'm going to show you how it's possible to use carbon dioxide to make a bubbly drink. So right here I have some Kool-Aid water, and we're going to be using dry ice to make it carbonated and fizzy. So just gonna make sure that the pieces are super small, because it's extremely dangerous to drink dry ice, because if you touch it, first of all, it like almost burns you because it's so cold. You don't want that in your throat. So I'm going to take some pieces, and put them into the drink. Once the dry ice has fully sublimated, you can try it.
So our
So enough bad puns later. It's time. We've come to the end of the session. So if any of you are interested in an interactive wrap up, you are more than welcome to unmute yourself, share your first name, what you like about STEM, and what has been your favorite part about the Inspiring Future STEM Stars program so far. So, closing remarks. I hope you have all enjoyed this sixth session. Please remember to register for our last session on August 19th. It will consist of a panel featuring many women in the STEM field. If you have any suggestions on how I can make the next session better, please email me at inspiringfuturestemstars@gmail.com, and I will stay on Zoom for a few minutes if you have any questions. Thank you.